All right, this video is for Math 3, Section 3.6. We're going to be looking at just the first problem of our homework assignment, which was number 9, was the first one in ours. So it says select all the zeros of the polynomial function. So a couple things here. One, it never mentions that synthetic division is our only option that we've learned so far. It does not say synthetic division is what you should try. The other thing is, even if we knew synthetic division was what we should try, where do we begin? Okay, well, we first start with the coefficients of this. Whoops. Let's clear that off and start fresh. All right. 1 is right there. So our coefficients would be a 1, -6, 7, 6, -8. Whoa. Okay, and then we'd have a number in the box. So our number in the box, it turns out there's certain numbers you don't have to try. I can just look at this and say 3 would never ever work. 5 would never work. 6, 7, 9, 11, 12, 15, 19, 17, they'll never work. How can I tell all that? I'm looking at 8. Okay, it doesn't even matter that it's -8. The only ones that could possibly work for our synthetic division are 1, 2, 4, or 8. 3 does not divide, so it's got to be one of the factors of 8. The other thing is, it could be positive or it could be negative. That's a really bad looking my pen's not working right, but that's positive and negative. I'm going to switch to regular paper here for the rest of the problem. But those are the important coefficients that you need to copy down. And then we need to do synthetic division. Okay. And I would suggest doing it on paper every time and being organized about it. And you'll make less mistakes, and you'll have that to refer back to. All right, and we talked about this in class, and I can't stress this enough. Actually, I put my box a little bit high. I should put it sort of in line over here. Ignore that. The reason we're doing this, they gave a f of x. We're looking for the zero so we can graph it. And again, if you're like, why don't I just put this in Desmos? You could. But how's Desmos doing it? How do we know how to do this stuff? How do you do it with calculus and stuff like that? What are you going to do when you get to calculus? What are you going to do? No, seriously. You want to practice this. That's the whole point of this. The factors, as we said, are possible factors, or possible zeros are factors of 8. Let me say that correctly. The possible zeros are the factors of 8. I'm just going to go out on a limb here. I don't know 2. This might work. I'm just guessing here. Honestly, there's no way for me to know. I'm going to run through the synthetic division, and we're looking for something special to happen at the end. -8. Okay, I multiply, add, multiply, add, multiply. Oh, look at me. Honestly, I did not know that was going to work. I swear. I'll show you why we would have gotten lucky eventually anyways. But 0 is a factor. Okay? Sorry, 0 is the remainder. 0 is the remainder. Okay, that's what we want. Okay, because let's go back to elementary school. Don't you wish? No, if we said, if your teacher said, does 20 divide by 3? And you say, no. And she'd say, why not? Because it doesn't have 0 remainder. Okay, we want a 0 remainder. We need a 0 remainder. So we're super happy when it has 0 remainder. Okay, let me move my camera here. There we go. Okay, what now, Sherlock? Okay. Well, we bring this down, bring this down, bring this down, bring this down. What this is, if that's the remainder, then this is the constant. That's the x squared, and that's the x cubed. And this makes sense because we start with x4. We did one division, and we brought it down a level. We went from x4 down to x3. What about this 2? 2 was the 0, x minus 2 is the factor. 2 is the 0, x minus 2 is the actual factor. Again, that goes back to how we do log division and how we do synthetic division. And we make the opposite, I said, when we do the synthetic. So there's all addition. Multiply and add, multiply, add, multiply, add, multiply, add. Right. So it's the opposite, so that we can add all the way through. Oh, I don't need that yet. We need to synthetically divide this wonderful thing. All right. So we're going to take this thing now, 1, -4, -1, 4, and use more paper to break it down more. Now the good news is we broke it down already at level. The only possible factors are factors of 4. So that'd be like 1, 2, or 4. Now they could be positive or negative, but we take a guess and hopefully we're right. So we bring this down. 1. I should have made this line straight. That's ugly. My apologies. Let's see if we can do it in our head. 2 would give us negative 2 times 2 would give us 3, which gives us like there's no way to cancel with a 4. Something's messed up. Let's try a 4. 4 would give us a 0. 0 would give us a 1. Oh, that might work. Look at that. 4 times 1 would give us a 4. That would give us a 0. 4 times 0 is 0. Uh-oh. Negative 1. Negative 1 is 0. Boom, boom, boom. What the heck did we find? We found, yay, 0 remainder. We need that to happen every time. We just got lucky here. Or actually, we tried 2 in our head and we know it wouldn't work. 0 remainder, negative 1 right here. So your negative 1 is your constant. 0x, x squared. And what about the 4? The 4 made the factor x minus 4. Okay. 4 is the 0, x minus 4 is the factor. And what about this x minus 2? Yeah, that one too. It comes along for the ride. Oy, oy, oy. I apologize, this is looking a little messy here, but here's what we did. Let's look back so far. We took this, and we did one round of synthetic division, and got it to a level 3. Did another round of synthetic division, got it to a level 2. This we're now going to rewrite as x minus 2, x minus 4. I don't like that 0x. I'm going to call this x minus 1. Oh my goodness. That's something called difference of squares. And if you recognize it, you'll recognize it factors very nicely. X squared would be x and x. And the only way to get negative 1 is a minus 1 and a plus 1. One has to be plus, one has to be minus. Whew. Yeah, thank goodness we are done. Got some bad news for you. We're not done. What? What are we after here? Again, we're after the zeros. We're after when does this thing equal 0? Oh my goodness. Okay, don't worry. We're almost done. The hard work is already done. We got it factored. This is huge. This is huge. We took it a 4th degree to 4 separate factors. Why? Well, because the original question, I don't know how to solve. But when these all equal 0, I can split them up and set each part equal to 0. Aha. Why? Because each separate part of this, the only way to get 0 out of this equation is one of these factors must be 0. Alright. Let's go plus 2, and you get, instead of x minus 2, you get x equals 2. X minus 2 is the factor, x equals 2 is the 0. 2 is the 0 because when you plug in 2, you'd get 0. Same thing here. X equals 4. Because when you plug in 4, you'd get a 0. Same thing here. Even though it's x minus 1, positive 1 is a 0. And ditto here, except for it's reversed. Alright, wow, that's a lot of work, and thanks for sticking with me here. Now you can go back on the big ideas and click your zeros. Get all that stuff out there, click, 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 click. And again, you could guess and check, but don't do that, okay? That's going to work only for so long. Really, I know this is a pain. I know it's a lot of work to go all the way through that synthetic division. Look at that. But feel proud of yourself. You're now doing problems that take about a whole sheet of paper to do. Okay, this is tougher math. It is Math 3. But like I said, it built on Math 2. Okay, Math 2 would have solved like x to the 3rd equation. You're solving x4, and eventually you can handle any level. The good news about it is that if you have the time and you have the paper, you could solve a 5th degree, a 6th degree, a 7th degree, as many degrees as you have time for by this method. Would you want to? Probably not. At some point, you'd probably write a software code that would solve it for you. And now you see the value of all that, doing all that. How would you write it into computer language to make a computer do it? Or you'd search for a different way. You'd say, I know there's a shortcut. Let me check YouTube. All right. And you're welcome to do that. I encourage you to do that. I just want to make sure that whatever method you use makes sense to you. All right. So bring questions to class or bring questions to tutorial, and we'll see you soon.